Hi everyone. Um, this is going to be a very long video. I'm not going to lie to you. So you might want to sit down with a cup of tea or whatever your poison is and something to write with. And yeah, basically I'm going to try and take you through the whole of the electronic product specification in loads and loads of questions. What I suggest you do is use kind of play and pause. So let the question come up. I'll give you a couple of seconds and then I'll give you the answer. But if you pause it and attempt to answer that yourself as way of revision, that might work. I apologise to everyone else on my YouTube channel. This video is mainly aimed at my students, anyone else out there really who's doing electronic products exam, which is on Tuesday next week, so good luck with that. I can't promise this will cover absolutely everything, and I can't promise it will go into loads of detail about each of the topics either. This is really just a recap quiz, so if you want to learn more about any of the bits or it's not clear, I suggest you go and watch some of my other videos on my channel, or read a book, a revision guide if you got one of those. Alright, here we go. Good luck. As I said, some of them you can just wait and see the answers. Others I'll verbalise the answer over the top because it's a bit quicker than writing it down. Alright, here we go. Let's hope this works. Okay, there'd be your answers. You want disposable batteries for the TV remote, something that's solar powered, and don't forget you need a rechargeable battery as well if it was a solar light. You need somewhere to store the energy. You want something small for a birthday card and something rechargeable for a cordless telephone. That's why those are picked. Next question. Remember, pause the video, see if you can draw it. Okay, if you drew something like this, well done. When we put cells together in series, they become a thing called a battery, and their combined voltage, you just add them together. So 3 times 1.5 gives you 6. No, it doesn't. It gives you 4.5. I'm a moron. There should be 4 batteries there. So anyone who's this took me ages to write this quiz, I do apologise. I am prone to making mistakes, so do call me out if you spot any. This would give you 4.5 volts. If I wanted to make 6, I should have drawn an extra one. So, what's that? Okay, that component is a voltage regulator. Its device is to regulate voltage, funnily enough. So what it does is allow us to power our circuit using a 9-volt battery, yet coming out of this output leg we will only ever get 5 volts. We only get the last number in the name. So our little PIC chip here will be only receiving a maximum of 5 volts because that's all they can handle without blowing up. But meanwhile our buzzer, which may need 9-volt supply, can get all of the 9 volts. So it's just a method of altering voltages in a circuit. You can buy these in a little device. Right, what do they sense and what causes the motor to turn? Give you a couple of minutes to think about it. Okay, this top left would be a dark sensor. The motor will spin when it gets dark. This will be a light sensor, as in the motor will turn the bright, or when it starts to get light. This will be a hot sensor on the bottom left. The motor will turn when it starts to get warm, and this will be a cold sensor. How do I remember? Or if you remember when you have a potential divider, if you remember my dodgy little phrase, cold and dark in the basement, warm and sunny on the roof. If the sensor is on the bottom and it's a light sensor, or a thermistor, it is a cold sensor or a dark sensor, cold and dark in the basement if it's on the bottom. And if it's on the top half of the potential divider, i.e. on the roof up high, it would be a warm or sunny, as in light detector. Okay, I hope that helps you remember. This is known as a sensing circuit. Anywhere you see that and a transistor, you can swap this component out for any output you like, LED, buzzer, motor, whatever it may be. Next. So have a look at the resistors in both of those circuits. You should know what job each of them does. Pause your video, see if you can guess. Okay. This resistor we would call a pull-down resistor. This resistor is protecting the base of the transistor from too much current. This resistor is a pull-up resistor. We've already discussed that one, protecting the transistor. and this resistor is protecting the LED from drawing too much current. So they do two jobs: protect from too much, or they either pull down or pull up. If you don't know what that means, watch the other video. Next. This requires a bit of maths. I'll let you read it and I'll put the answer up. Okay, here's your answer. Use Ohm's law. V equals IR. You'll need to rearrange it so that R is VI. Voltage drop means the LED uses 1.5 volts, so you can subtract that from what your battery is providing. So 9 minus 1.5 volts drop gives us 7.5 to play with. Plug that and the current into your equation, so 7.5 divided by 25 milliamps. Convert milli, that you divide by 1000, so you end up with 7.7 over 0.025, should give you 308 ohms, ideal. You should know about resistor series. You cannot buy resistors in every value under the sun, so what you would do is find the nearest multiple of 10 near to that number. So you'd have 300 or 330 would be the multiples that are near to 308, but 330 would be the one you pick because you want a stronger resistor rather than a weaker one. It's better to overprotect than underprotect. Next question. Right, you either know these or you don't, so test yourself. What do the letters stand for? And what do they mean in terms of indices? I have got a video on this, or there's plenty out there in your maths textbook. I'm afraid I can't teach you it now, but that's what they translate to. Tera, giga, mega, kilo, milli, micro, nano, pico. Remember, it's just adding zeros or removing zeros. Minus means you move the decimal point to the left. No minus means you move the decimal point to the right. There is a video on this if you need to watch it. You will need to memorize probably kilo, milli, mega and micro. The 4 in the middle are you're most likely to come up. What's the total resistance? Anyone should be able to do this. If they're in series, you add them together. 1 plus 3 plus 2.2 gives you 6.2. Easy. 3 jobs a capacitor can do, and the difference between electrolytic and non-polarized. You can make a time delay, you can smooth the power supply, or you can reduce switch bounce. The electrolytic types are the ones that have a plus and a minus, an anode and a cathode, and must be connected the right way around. The other type don't matter. I have a video on capacitors if you need to watch that and you don't understand what I'm talking about here. Okay. Show where you'd add a diode to prevent some idiot putting the battery around the wrong way. Pause it, guess where you'd put it, unpause it, and you'd put it right about there. Make sure the arrow is pointing away from the plus end of the battery. This means current can flow that way, but not back. Next question. This is just for you to work out, so pause the video now and work them out. If you can remember the color code, do remember it's given to you in the exam. You just need to know how to use it. Your correct answers are and if you can convert to K or mega or whatever it may be, then you should do, but you'll probably get the mark either way. Next question. Okay, the first one, basically it's whatever 5% of 10,000 is. Take that away or add it on. So 5% of 10,000 is 50. So the minimum it could be is 10,000 less 50, which is 9,050, or 10,000 plus 50, which is 10,050. So when you brought it, it would guarantee to be a number somewhere between that and that. Why do they have tolerance? There's your answer. Manufacturing. Remember, the lower the number, what I mean here, the lower the tolerance, sorry, I've misspelt that, or misworded that, the more expensive it will be. So if we go back to here, a brown tolerance resistor would be more expensive than a silver banded one, because it would have to be made more accurately, and that takes time and effort. You either know it or you don't. Draw them down while you pause it, and your answer should be that. Push to make, push to break, single pole, single throw, double pole, double throw. In case you're unaware, the pole is this bit, the bit that moves on the switch. The throws are the number of positions it can move to. This has 2, so it's double throw. No, I've done that wrong again, Mr. Winter, you're an idiot. Sorry, when you've written 85 questions you do make a mistake. What I've drawn there is a single pole double throw switch. I'm just going to amend that, I do apologise. Okay, if it only had one position and the other position was connected to nothing, it would have been the single pole single throw. Okay, next. Right, pause it and draw it. There we go, that's your answers. LDR senses light, or changes resistance with light. Thermistor changes resistance with temperature. Phototransistor conducts when, or has low resistance when light is shining on it. Potentiometer changes resistance when you turn a dial. Basically it uses rotary motion to change resistance, and so does the variable resistor. It just has two connections rather than three. These are essentially the same thing. Right, there are more smart materials. See if you can define what each of those do while I pause the video and name a use for each. And your answers would be changes from insulator to conductor for quantum tunneling composite with pressure. You could use those in switches in a hazardous environment where you don't want to make sparks when you press the switch contacts together, or for a touch sensor for many different applications. Those two change colour either with light or with temperature. Good example are those glasses you can buy that turn into sunglasses when you walk outside. They go dark. Or for the thermochromic baby bath temperature, those little things you put in the bath that go red or green depending if it's warm or too cold. And those saucepans that have a red dot in the middle that goes red when the temperature is right for cooking. Shape memory alloy, fire sprinkler sensors. When the fire gets hot enough, it makes the alloy switch bend back to its remembered position, which is open, allowing water to flow into the building, put the fire out. And glasses frames. And then number 4, piezoelectric material produces a voltage when squashed or struck. If you've ever played the Rock Band drum kit, there's one of those in each of the drum pads. Apologies, I'm just going to see how we're doing. 12 minutes, right. We're only 16 questions in, going to have to pick up the pace a bit. Okay. Draw them. You either know them or you don't. Pause it. Okay, answers. There you go. If you don't know how these are labelled or how they work, watch my other video on component symbols. Name these and label. Pause it. Okay, there's your answers. Diode, anode and cathode. A thyristor, anode, cathode and gate. This is a one-way device. This is a latch. If you don't know what it is, look up the video. God, this is going to go on and on. Name those. Pause it. Transistor and a field effect transistor. This might sometimes be known as a bipolar transistor. It's the same thing. Collector base emitter, or CBE. If you're in my class the other day, do you remember I said you can remember it as like CBA, can't be burst, but say it in an Irish accent. CBE. If that made no sense to you on internet land, don't worry about it. It was something we came up with as a class the other day. Right, and your field effect transistor. Drain on the top, source on the bottom. I believe on my video for FETs I've got these two round the wrong way because I'm a muppet. So sorry about that. You drain the battery and you source to whatever you're trying to turn on. I really hope I've got it right here. If in doubt, Google it. Google's way smarter than me. Next, name the two circuits. Pause it. In fact, unpause it, because you should be able to go BAM, that's a comparator, and BANG, that's an inverter, or an inverting amplifier. Very different, but they both use an op-amp. There is a video on this. Funny that. Calculate the gain of that circuit. Easy. Pause it, have a go. Formula is here, it's given to you. Alright, there's your answer. You take the feedback resistor and divide it by the input resistor, and that gives you your gain. So minus 10k, this is the feedback one, the one that goes around looping, and 2k is the input resistor. Minus 10 over 5 gives you minus 5. The gain is minus 5. That means whatever you put in here gets boosted 5 times, but in the negative direction. So if I put 2 volts in, I would get 10 volts out the other end, but minus 10 volts. Explain that, pause it, see if you can write a paragraph that explains the whole thing. Here's your answer. It should be that detailed. Watch the video on op amps, but essentially when the plus is plusier, it pluses. That's my way of remembering it. Or in technical terms, you should be saying to the examiner, when the non-inverting input is at a greater voltage than the inverting input, the op amp sources current. So that means when it gets cold, this voltage goes up, this then sources, meaning that LED flashes, and when the opposite is true, when it's warm, the chip sinks current and diode 2 lights. That was a very brief explanation. Go watch the video on op amps if you've not got a clue what I'm yabbering on about. But that's the explanation level you would need in an exam. This would probably be a 6 or 7 mark question. Okay, you tell me, what's it called? Pause it and work it out. Alright, here's your answers. Known as a potential divider. Whenever you see a resistor on top of a resistor, we call it potential divider or voltage divider. Call it that one in your exam though, potential divider. And what is the value of V out? Well, the nice people at the exam board give you the formula, you've just got to stick the numbers in. So, it's voltage in, which is 9, times the resistor 2 over R1 plus R2, plug those numbers in, you'll get 4.5 volts. Idiot check time, if you end up with a number bigger than what went in, you've definitely done something wrong with your maths. And another quick fix, if these are both the same value resistors, what you get out will always be half of what goes in. The maths proves that, but I won't bother doing it now. Alright, next. There's your answer. That's a Darlington pair, and just for information, that's why I'd use one. They're more sensitive than a single transistor, they can amplify more current than a single transistor, and if you go and buy them, they come in one box anyway. If someone asked you to label the connections, you've still got one collector, one base, and one emitter. Can't be erst. CBE. Next. If it's 2016 and you're watching this, this is, in my opinion, is a likely circuit to come up because the theme for your exam is games that test and hand and eye coordination. This could be adapted into a steady hand game, and it is of course a latching circuit. So the thyristor causes the latch, by the way. When I push this button, send energy into the thyristor then conducts. Even if I've let go of the button since, it still remains conducting, which means there is a path opened up for the speaker, so the buzzer sounds. So basically I temporarily touch that button, the buzzer will come on and stay on. The only way to turn it off is to short it out or short the thyristor out by pushing this button on the right. Next. Name those two. Pause it. Look at it. Spot the clues. Here's your answer. That's a monostable. That's how you can tell. That's an astable. That's how you can tell. Moving on. Let's have a look. How far are we? Oh, 27. Dear God. We're at 18 minutes. I may have to do 2 videos. Right. This one, pause it and see if you can work out all of those things. Time high, time low, frequency, mark space. Remember the formula are given to you. You've got to plug the numbers in. Pause it, see if you can do it. This should take you a few minutes. And if you've unpaused it, here's your answers. Okay, if you got the wrong answers here, chances are you didn't convert K to, so 8K, 8000 or 100 UF should be 0.0001 F. You've got to convert the values. If you don't know what I'm banging on about, go watch the video on standard form. Next. This is easy, pause it. There's your answer. Sinking is flowing into a chip or a device, sourcing is flowing out. Op amps and 555 timers can both sync and source. Next. Okay, sketch it while it's paused, and you should have come back with something like that. Green is analog, red is digital. excuse me, with the digital, make sure the bottom of the square wave, if you like, goes right to 0 and the top goes up to whatever the voltage on your graph is. The analog can be any crazy shape as long as it doesn't do a loop-the-loop or go back on itself. Next. Pause it. Okay, the mark would be from here to here on the pulse. That's the time it's on or high for. The space is from here to here on the bottom. It's the time it's low for. Period is how long it takes for one whole pulse to happen, so that would be from here to here on the graph. The amplitude is the size of the pulse, like vertically, so from 0 up to, well, technically from the bottom of the pulse to the top, measured in volts. And the frequency is just how many times in 1 second does the pulse happen. So we've got 1, 2, 3, so this would have a frequency of 3 hertz. You measure frequency in hertz. Next, see if you can do this. You're given the formula in the exam, but not in that format. You're given it as V equals IR. Pause it and do it, and you should get the answers that. On this one, remember to convert K. You'll get your answer in amps. It would be a good idea for the exam to convert to milliamps if you know how to. Next. You're given that in the exam. C times R, we're talking these two. This is a monostable circuit, if you can remember. It's got the switch on pin 2. Your time delay should be 10 seconds. Make sure you convert U, make sure you convert K, or you'll get the wrong answer. For any of these maths questions, by the way, for anyone out there listening, if you write the formula down that's given to you in the front of the paper, you'll get 1 mark usually. You'll also get a mark or lose a mark for forgetting the units. If you don't write seconds, volts, amps, whatever the question's about, you will lose a mark. Next. Okay. Amplify current or act as a switch. They both do that job. Why would you pick a FET? For that reason. Pause it and read it. I'm going to move on. What is back EMF and why is the diode there to prevent it? There's your answer. Pause it and read it. This is in my video on diodes if you need a better recap than that. If in doubt, if you've got a motor or a relay, slap a diode on it in parallel with it like that, pointing up to positive. Next. Right. Be good if you could name some examples as well. Here's your answer. Pause it and check with what you had. Next. Your 3 methods: CAD, breadboard, or stripboard, veroboard. If you're not sure what they are, I'm afraid I haven't got a video on this, but CAD is using computers. Breadboards are little plug-and-play devices. I'll show you next. Stripboards are ones that you solder to, strips of copper with pre-drilled holes. Advantage of CAD, you don't have to build anything. It's all virtual. You can email it to people. Advantage of breadboards is it's nice and quick to make changes, and you can test it for real and check it. Because remember, things in CAD don't always work as you expect. Advantage of stripboard, veroboard, it's more permanent than breadboard and guarantees it will work because you're actually building it in real life. However, it's really hard to make changes because you've got to unsolder stuff. They've all got their pros and cons. For my students, there is a PowerPoint on the student revision area that I've done about these 3, so read that. Photo etch method. See if you can write down the 5 steps. So this is how we've made all your circuit boards at school for the last 2 or 3 years. There's your answers. Print it on film, put it in the light box, take it out of the light box in developer, out developer into the acid, out of the acid, rinse, clean, drill, bosh. And an alternative method, CNC routing. YouTube that name and you'll find loads of videos of people making circuit boards that way if you're not sure. Next. Oh crikey. Alright, I've messed that up then. Just read that one and see if you agree. Moving on. By the way, I hope you're pausing this and doing it. Oh, another one I didn't put the hidden comments on. Right, anyway, these are some methods we could use to make products more sustainable. there will be a tree-hugging social, moral, cultural question in your exam somewhere. It could well be one like this. So, reduce the number of materials or components used. If you reduce that, you'll make the part better for the environment because you're building less. If you make it recyclable or build it from recycled materials, that will also help because you're using less energy to obtain the materials and not damaging habitats digging them up. Repair. Make it easy to repair. If you can change bits of it, upgrade it, change the battery. Imagine if you could just click a brand new screen on your iPhone when you dropped it. How cool would that be? Make it easy to repair means the product will stay in life longer, meaning fewer need to be made. Reuse. If the part can be upgraded or reused for a different purpose, that is good. Think about energy efficiency, so putting in power switches, using LEDs instead of bulbs, energy efficient components, automatic power off mode, and labeling. All parts should be labeled to make them clearer for recycling. That will also help. If you can write a load of waffle about those, you'll get some marks if that's your question. Next, draw and label, pause it. There you go, there's your answers. They're the only 3 you need to know for this exam. Next. Here's your answer for analog. And here's your answer for digital. Right, just going to check on the time again, I do apologise. Oh, 26 minutes and I'm about halfway. What I'm going to do, I'll get to 45, I'll pause the video and then I'll do a part 2. Repeat the truth table for the following. Couple of minutes to work it out yourself. Pause it. Here's your answers. You've got an AND gate here, so that is only on when A and B are on. By the way, in binary, 1 means on, 0 means off. 1 on, by the way, just means there is voltage there, 0 means there is no voltage. And because this guy's a NOT gate, which is an inverter, everything that is at C that goes in will be flipped when it comes out of Q. So 0 becomes 1, and so on. There's your answer. Next. Right, I'm just going to tell you, I don't think you'll have to draw one in the exam, but it's nice to know. These would be the coil connections. This is the coil. G is the soft iron core, or E is known as the armature. D is a pivot. C is insulating material. B are the switch contacts. F is some sort of spring. A would be the relay switch connections, in this case common in the middle, normally closed on the left, normally open on the right. Next. Okay, that is a SPDT relay. Those are the connections. These names, by the way, apply to any switch with 3 legs. Common, normally closed, normally open. It doesn't have to be bolted to a relay. The dotted line means this coil, which makes a magnetic field when energy is put into it, pulls the switch across. You use them for safety. Okay, and one more, and then we'll pause. Right. Actually, that'll be a good time to start the next video. So, go watch video 2 now, I guess.